Art in the Age of Algorithmic Creation. A report on the ethics, legality, and future of generative AI. Section 1. The anatomy of the new artist. How AI generates imagery to engage in a meaningful debate about the ethics of artificial intelligence, AI in art. One must first understand the mechanisms of creation. The processes by which these models generate imagery are not acts of simple collage or digital sleight of hand. They are complex computational systems built on distinct architectural and philosophical foundations. A grasp of these technical underpinnings is a prerequisite for evaluating claims of either creative inspiration or high-tech theft. The two dominant paradigms in modern image generation, generative adversarial networks, GANs, and diffusion models, represent fundamentally different approaches to the challenge of creating novel visuals from data. 1. The two dominant paradigms. GANs versus diffusion models. The field of generative AI has been shaped by the evolution of its core architectures. While both GANs and diffusion models can produce stunning imagery, their methods for doing so are starkly different, leading to unique strengths, weaknesses, and ethical implications. Generative adversarial networks, GANs, first introduced in 2014, GANs operate on a principle of competition. The architecture consists of two neural networks locked in an adversarial min-max game, a generator and a discriminator. The generator's task is to create synthetic images, starting from a vector of random noise. The discriminator's task is to evaluate these images and distinguish them from real images taken from a training dataset. The training process is a continuous feedback loop. Initially, the generator produces random static, which the discriminator easily identifies as fake. This feedback forces the generator to adjust its parameters to create slightly more plausible images. As the generator improves, the discriminator must also become more discerning. This relentless competition pushes both networks to become more sophisticated, culminating in a generator that can produce images nearly indistinguishable from reality. Once trained, GANs can generate new samples very quickly, making them efficient for applications requiring rapid output. However, this training process is notoriously unstable. GANs are prone to a problem known as mode collapse, where the generator discovers a small number of images that consistently fool the discriminator and produces only minor variations of them, sacrificing diversity. Diffusion models represent a more recent, stable, and often higher quality approach to image generation. Instead of a competitive dynamic, they employ a process of iterative refinement inspired by thermodynamics. The process consists of two main phases. First, forward diffusion. In this initial training phase, a real image from the dataset is gradually destroyed by adding a small amount of Gaussian noise over a series of hundreds or thousands of steps. This diffusion process continues until the image is transformed into pure, unstructured noise. Second, reverse diffusion. The model, typically a U-Net architecture, is then trained to reverse this process. At each step, it learns to predict and remove the noise that was added, gradually reconstructing the image. To generate a new image, the model starts with a canvas of pure random noise and applies this learned denoising process iteratively. Guided by a text prompt, it slowly refines the static into a coherent and detailed image that matches the desired concept. This methodical approach allows diffusion models to capture complex data distributions and produce a wider variety of high-fidelity images. The primary drawback is computational cost. The multi-step generation process is significantly slower and more resource-intensive than a GAN single-pass generation. 1. The engine of creation. Latent space and text-to-image translation. AI models do not see images or read text in a human sense. Instead, they operate within a high-dimensional mathematical realm known as latent space. An encoder is a neural network component that compresses complex high-dimensional data, like the pixels of an image or the words in a prompt, into a much smaller, denser numerical representation called a vector or an embedding. This compressed representation captures the essential semantic features of the input while discarding irrelevant information. Within this latent space, concepts have a geometric relationship. For instance, the the vector representing the word king minus the vector for man plus the vector for woman, will result in a new vector that is very close to the one representing queen. This demonstrates that the model is not merely memorizing data, but is learning abstract relationships between concepts. In a text-to-image diffusion model, the user's text prompt is first converted into a numerical embedding by a language model like CLIP. This text embedding then acts as a guide or condition for the reverse diffusion process. At each denoising step, the model consults the text embedding to ensure that the emerging image is moving closer to the semantic meaning of the prompt. The initial random noise provides the variation, ensuring that the same prompt can generate different images, while the text embedding provides the direction, ensuring the output is conceptually coherent. The public debate surrounding AI art often falls back on simplified metaphors. Artists and critics frequently describe the process as a form of automated collaging or stitching of existing works. Proponents, meanwhile, prefer the metaphor of learning or inspiration. The technical reality reveals that neither metaphor is perfectly accurate, but the underlying architecture of the dominant models lends more credence to one than the other. The process of diffusion models, in particular, challenges the collage metaphor directly. These models begin with pure, unstructured noise, not a collection of image fragments. The creation is a process of transformation from chaos to order, guided by an abstract conceptual understanding derived from the text prompt. This is functionally distinct from cutting and pasting pixels. While GANs can sometimes suffer from overfitting and reproduce training data more directly, the fundamental mechanism of diffusion is one-off synthesis, not replication. This technical distinction does not resolve the ethical debate, but it reframes it. The central question shifts from one of direct, literal copying to the more nuanced and complex issue of whether learning statistical patterns from a massive dataset of copyrighted work without consent is itself a form of theft. Here is a comparison of the two architectures regarding the core mechanism. For generative adversarial networks (GANs), it is an adversarial game between a generator creating images and a discriminator identifying fakes. For diffusion models, it is an iterative process of adding noise to images forward and then learning to remove it reverse. Regarding the training process, for GANs, the generator and discriminator are trained simultaneously, with each pushing the other to improve. For diffusion models, a model e.g. UNet is trained to predict and reverse the noise added in discrete time steps. Regarding generation speed, for GANs it is very fast once trained. It requires a single forward pass through the generator network. For diffusion models, it is slow and computationally intensive. It requires hundreds or thousands of iterative denoising steps. Regarding output quality, for GANs, they can produce high-quality, realistic images but may struggle with fine details and coherence. For diffusion models, they generally produce higher quality, more diverse, and more detailed images than GANs. Regarding training stability, for GANs they are notoriously difficult and unstable to train. They require careful balancing of the two networks. For diffusion models, they are more stable and reliable to train compared to GANs. Regarding the key weakness, for GANs they are prone to mode collapse, where the generator produces a limited variety of similar outputs. For diffusion models, they suffer from slow inference time and high computational requirements for generation. Finally, for prominent examples, for GANs, examples include Style GAN and Cycle GAN. For diffusion models, examples include Stable Diffusion, DALLE2, and Midjourney. The significant trade-offs between these two architectures suggest a future where the generative AI ecosystem is not monolithic. The vast difference in speed and output quality is likely to lead to market stratification. GANs, with their rapid generation capabilities, are well suited for tasks where speed is paramount and perfect fidelity is secondary, such as data augmentation for training other models or generating quick conceptual mockups. In contrast, diffusion models, with their superior quality and control, are positioned as the tools for high-end creative work, from fine art to detailed commercial illustration. This technological divergence means the economic impact on artists will not be uniform. Roles focused on rapid, low-cost content creation may face greater pressure from automation by GAN-like systems, while artists in high-concept fields may find themselves augmenting their workflows with the slower, more powerful diffusion models. Section 2. The Digital Quarry. The ethics of AI training data. If the generative model is the engine, the training data is its fuel. The debate over AI art's ethics moves from how the models work to what they are made of. It is here, in the vast digital quarries of data used to train these systems, that the allegations of theft find their most solid ground. The composition, scale, and methods of collection for these datasets are the primary source of the legal and ethical firestorms surrounding the technology. 2. 1. The fuel for the engine. LAION datasets. At the center of this controversy is LAION, Large-Scale Artificial Intelligence Open Network, a German nonprofit organization founded with the mission to liberate machine learning research by providing open-source datasets, tools, and models. LAION rose to prominence by releasing massive datasets of image-text pairs that were crucial for training a new generation of powerful text-to-image models, most notably Stable Diffusion. The scale of these datasets is immense. In August 2021, the organization released LAION 400M, a collection of 400 million image-text pairs. This was a deliberate attempt to replicate and democratize the type of massive, proprietary dataset that companies like OpenAI had used to train their groundbreaking CLIP model, the code for which was open-sourced but whose training data remained private. This was followed in March 2022 by LAION 5B, an even larger successor containing 85 billion pairs, making it the largest publicly available dataset of its kind at the time of its release. 2. The method of the harvest. Web scraping and common crawl. The creation of these multi-billion pair datasets was not an act of careful curation, but one of industrial-scale automated harvesting. The data was derived from Common Crawl, a publicly available repository of petabytes of raw web page data scraped from the internet. LAION's developers wrote scripts to parse this data, searching the HTML for image tags and treating the associated alt text attribute, a short description of an image for accessibility purposes, as the corresponding caption. To ensure a baseline level of quality, the resulting pairs were filtered using OpenAI's CLIP model. This model calculates a similarity score between an image and a text description. Pairs that fell below a certain threshold of semantic relevance were discarded. A critical technical and legal detail lies in how the dataset is distributed. LAION does not host the images themselves. Instead, it provides a massive metadata file containing the URLs pointing to the original images on the web, along with their scraped captions. Researchers and companies wishing to use the dataset must then download the billions of images themselves using this list of links. This structure is a deliberate and legally significant choice. By providing only links, LAION can argue that it is not distributing copyrighted material, merely indexing it. This strategy effectively outsources the act of making a copy, the central act governed by copyright law, to the end users who train the models, thereby creating a liability shield that complicates legal challenges. It is a calculated move to diffuse responsibility along a chain of data processing, making it more difficult for creators to target a single entity for the initial act of infringement. 2. The contents of the quarry. Copyright, consent, and contamination. The indiscriminate, automated nature of this web scraping process means the LAION datasets are a reflection of the raw, unfiltered internet. Consequently, they are rife with profound ethical and legal problems. The most prominent issue is the inclusion of vast quantities of copyrighted material. The datasets contain millions of works by professional and amateur artists, photographers, and illustrators, all scraped and included without their knowledge, consent, or any form of compensation. This non-consensual use of creative work as raw material for commercial AI products forms the basis of numerous lawsuits, including a class action suit in which artists are suing Stability AI and other companies, and a separate suit by a German photographer directly against LAION to have his images removed. Beyond copyright infringement, the datasets are contaminated with a wide range of harmful and problematic content. Studies and investigations have revealed that LAION5B contains image-text pairs depicting rape, pornography, racist and ethnic slurs, and malign stereotypes. An investigation by German broadcaster Bayerischer Rundfunk found that the datasets also contained large amounts of private and sensitive data, such as medical images and intimate photos of individuals, harvested from public websites without their consent. The most alarming discovery came in a December 2023 report from the Stanford Internet Observatory, which identified 3,226 suspected instances of links to child sexual abuse material, CSAM, within LAION5B. In response to this finding, LAION, citing a zero-tolerance policy for illegal content, temporarily took down both the LAION5B and LAION400M datasets. This incident underscored a catastrophic failure of ethical oversight in the pursuit of scale, revealing the dangers of a scrape first, ask questions later approach to data collection. This situation highlights a fundamental conflict between two competing philosophies. On one hand, LAION's mission to democratize AI research by providing open data is, in principle, a laudable goal aimed at preventing a handful of large corporations from monopolizing a transformative technology. On the other hand, the methodology used to achieve this goal, mass, unconsented appropriation of data, places the collective interest of research progress squarely above the individual rights of creators to control their work, maintain their privacy, and earn a livelihood. The ethos of the open-source software movement, where code is shared freely for the collective good, has been applied to creative content. However, the two are not analogous. Code is primarily functional, whereas art is deeply personal, often tied to an individual's identity and economic survival. This philosophical mismatch is the root cause of the entire ethical and legal conflict. The democratization of AI for researchers has been achieved through the non-consensual commodification of data from everyone else. Section 3. The case for high-tech theft. Copyright, consent, and compensation from the perspective of many artists and rights holders. The debate over generative AI is not a nuanced discussion of technological progress, but a straightforward case of mass-scale copyright infringement. The core argument is that multi-billion-dollar technology companies have built their products on a foundation of creative work taken without permission, credit, or payment. This section will articulate the legal and ethical arguments that form the case for AI as a form of high-tech theft. 3. 1. The artist's indictment. Someone's profiting from my work. The harm alleged by artists is both personal and financial. For creators like Kelly McKernan, an acrylic and watercolor painter, the impact was visceral. They began seeing images online that mimicked their distinctive style, clearly generated by AI models that had been trained on their art and prompted with their name. This experience, shared by countless artists, fosters a sense of violation and powerlessness. McKernan's statement, "At the end of the day, someone's profiting from my work. I had rent due yesterday, and I'm $200 short," powerfully connects the abstract debate over data to the concrete reality of artists' livelihoods. The central indictment is that AI companies are leveraging vast sums of venture capital to build immensely valuable enterprises, while the essential raw material, the training data, is being taken for free. Ed Newton-Rex, a composer who quit his role at an AI company in protest and founded a campaign against unlicensed data scraping, frames the hypocrisy starkly. Companies spend millions on engineers and billions on computing power, but expect to take the third, training data, for free. This perspective rejects the tech industry's framing of art as mere data and reasserts its nature as people's work, the product of human labor, skill, and expression that deserves compensation. 3. 2. The legal battleground. Derivative works and mass infringement. These grievances have moved from social media to the federal courts, with artists, authors, and stock photo agencies filing a wave of lawsuits against major AI developers. A landmark case is the class action suit filed by artists Sarah Anderson, Kelly McKernan, and Carla Ortiz against Stability AI, creators of Stable Diffusion, Midjourney, and the online art gallery DeviantArt. These lawsuits are built on several core copyright claims. First, direct copyright infringement. This claim targets the initial ingestion phase. To train an AI model, companies must make digital copies of the images in their dataset. The plaintiffs argue that making these copies of billions of copyrighted images without a license is a direct and massive violation of their exclusive right to reproduction. Second, creation of unlawful derivative works. This argument extends beyond the training phase to the output of the models. Plaintiffs contend that the AI models themselves, as well as the images they generate, are fundamentally derivative of the copyrighted works they were trained on. Because these generated images can mimic specific artists' styles and compete directly with them in the market, they are alleged to be infringing derivative works. Other major lawsuits, such as one filed by Getty Images against Stability AI, add further claims, including trademark infringement for reproducing watermarks and violation of terms of service for scraping content from their site. 3. Deconstructing fair use. The AI company's core defense in the face of these allegations. AI companies have raised a powerful shield, the doctrine of fair use. This provision in U.S. copyright law allows for the limited use of copyrighted material without permission for purposes such as criticism, commentary, news reporting, teaching, or research. Whether a use is fair is determined by a balancing test of 4 statutory factors, which are at the heart of the current legal battle. 1. Purpose and character of the use. This is the most critical factor for the AI companies. They argue that using images to train a model is highly transformative. The work is not being used for its original aesthetic purpose, but as a source of statistical information to teach a new system how to create. Some judges have been receptive to this, with one describing the use of copyrighted books to train a large language model as among the most transformative we will see in our lifetimes. 2. Nature of the copyrighted work. This factor generally favors the artists. Creative and artistic works are at the core of copyright's intended protection, making their unauthorized use less likely to be considered fair. 3. Amount and substantiality used. AI models are trained on the entirety of the copyrighted works, which typically weighs heavily against a finding of fair use. The companies counter that in the context of a dataset containing billions of images, the contribution of any single work is infinitesimally small. 4. Effect of the use upon the potential market. This is the artist's strongest argument. They contend that AI-generated images serve as direct market substitutes for their own work. A user who can generate an image in the style of a particular artist for free or for a small fee is a lost customer for a commission or a print sale. This, they argue, directly harms their ability to license and profit from their work, a key consideration in the fair use analysis. The entire legal conflict is a symptom of applying laws written for an analog era to a problem that is native to the digital world. Copyright law is fundamentally based on the concept of a copy and its distribution. It is struggling to adapt to a technology that learns from data rather than explicitly reproducing it for human consumption. The central legal question, whether ingestion for training is a form of reproduction infringement or a form of analysis fair use, does not fit neatly into existing legal frameworks. The court's reliance on the transformative use doctrine, a concept developed to handle cases of physical media like parody and collage, is being stretched to its conceptual limit to cover the statistical analysis of petabytes of data. This mismatch forces judges into making difficult and sometimes contradictory analogies, leading to the legal uncertainty and conflicting initial rulings that currently define the landscape. 3. The human authorship doctrine. Who owns the output? A parallel legal battle is being fought over the copyright status of the images the AI generates. The U.S. Copyright Office has consistently held, and federal courts have affirmed, that copyright protection can only be granted to original works of authorship created by a human being. The landmark case is Thaler v. Perlmutter, where a court upheld the Copyright Office's refusal to register a work that the applicant, Stephen Thaler, claimed was created autonomously by his AI system. The court reasoned that the Copyright Act implies an author must be human. This does not mean AI cannot be used as a tool, analogous to a camera or a paintbrush. The Copyright Office has clarified that AI-assisted works may be copyrightable, but what matters is the extent to which the human had creative control over the work's expression. If the AI determines the expressive elements of its output, that output is not a product of human authorship and cannot be copyrighted. This human authorship requirement creates a paradoxical legal gap. If an AI-generated image is deemed to be an infringement of the works in its training data, but it also cannot be copyrighted because it lacks a human author, it exists in a legal no man's land. The work is simultaneously illegal to create, as an infringement, and impossible to protect, as an uncopyrightable entity. This scenario poses a massive risk for the commercialization of generative AI. A company offering a text-to-image service could be sued for the infringing output its model produces, yet it would be unable to claim ownership of that output or prevent others from copying it. This creates a fundamentally unstable business model where companies assume all the liability of creation with none of the legal protections of ownership, a paradox that may ultimately force a change in either the law or the technology itself. Here is a summary of some of the major court cases. Case: Anderson et al. Versus Stability AI et al. Plaintiffs: Sarah Anderson, Kelly McKernan, Carla Ortiz as a class action. Defendants: Stability AI, Midjourney, and DeviantArt. Core allegations: direct copyright infringement for training, creation of infringing derivative works. Key defense arguments: fair use. Outputs are new creations, not derivatives. Models store statistical representations, not copies. Current status: ongoing. The court has allowed the direct infringement claim against Stability AI to proceed, rejecting the argument that the model only contains unprotectable data. Case: Getty Images versus Stability AI. Plaintiff: Getty Images. Defendant: Stability AI. Core allegations: copyright infringement, trademark infringement for replicating watermarks, violation of terms of service. Key defense arguments: fair use, transformative use of images for training a new technological system. Current status: ongoing in both U.S. and U.K. courts. Case: Thomson Reuters versus ROSS Intelligence. Plaintiff: Thomson Reuters. Defendant: ROSS Intelligence. Core allegations: direct copyright infringement for using Westlaw legal summaries to train a legal research AI. Key defense arguments: fair use, transformative purpose. Current status: District Court granted summary judgment for Thomson Reuters, rejecting the fair use defense but noted the AI was not generative. Case: Authors Guild et al. Versus OpenAI et al. Plaintiffs: John Grisham, George R. Martin, Authors Guild in multiple suits. Defendants: OpenAI and Meta. Core allegations: mass-scale copyright infringement for training large language models on copyrighted books without permission. Key defense arguments: fair use. Training models is a transformative use that does not substitute for the original books. Current status: ongoing. Courts are grappling with early motions to dismiss, with judges expressing that these are novel and boundary-pushing legal questions. Section 4. The case for creative inspiration. AI as tool and collaborator countering the narrative of theft is a vision of generative AI as the next evolutionary step in a long history of artistic tools. This perspective frames AI not as a replacement for human creativity, but as a powerful collaborator, an engine for inspiration, and a means of democratizing artistic expression. Proponents argue that the anxieties surrounding AI echo historical reactions to past technological disruptions, which ultimately enriched rather than destroyed the art world. 4. 1. A historical echo. From today, painting is dead. The current furor over AI art bears a striking resemblance to the art world's reaction to the invention of photography in the 19th century. When the daguerreotype was introduced in 1839, it was met with fear and derision from many in the established art community. The French painter Paul Delaroche famously declared, "From today, painting is dead." Critics like the poet Charles Baudelaire labeled photography art's most mortal enemy, dismissing it as a soulless, mechanical process for the lazy and untalented. These criticisms, that the new technology was a shortcut that devalued skill, lacked human emotion, and would put artists out of work, are nearly identical to the arguments leveled against generative AI today. History, however, shows that photography did not kill painting. On the contrary, it liberated it. freed from the commercial and artistic pressure to produce faithful, realistic representations of the world, a task the camera could now perform with greater efficiency. Painters were able to explore new frontiers of expression. This technological disruption was a key catalyst for movements like Impressionism, which shifted the focus of art from objective reality to the subjective experience of light, color, and emotion. Photography did not replace painting, it spurred it to evolve. Ultimately, it expanded the definition of what art could be, creating an entirely new medium while enriching existing ones. Proponents of AI art argue that we are witnessing a similar paradigm shift today. For the modern collaborators, artists embracing AI far from being a monolithic threat, AI is being adopted by a growing number of contemporary artists as an integral part of their creative process. These artists are not simply typing prompts into a generator. They are designing complex systems, curating datasets, and using AI as a collaborative partner to explore ideas that would be impossible to realize through traditional means. Xiaoguan Chung is a pioneer in the field of human-machine collaboration. Her work often features performances where she draws alongside robotic arms that have been trained on her past work. The robots act as extensions of her own artistic memory, responding to her gestures in real time to co-create intricate, large-scale drawings that are neither fully human nor fully machine. Rafik Anadol, a Turkish-American artist, uses AI to transform vast, abstract datasets into mesmerizing, immersive installations he calls data sculptures. For his work unsupervised, exhibited at New York's Museum of Modern Art, Anadol trained a model on the entirety of MoMA's digitized collection. The resulting installation is a massive, ever-changing screen on which the AI dreams of new, hallucinatory artworks based on its learned understanding of 200 years of art history. Linda Daunia, a Senegalese artist, directly addresses the ethical concerns of data scraping by training her models exclusively on her own body of work. She uses generative adversarial networks, GANs, fed with her abstract paintings and drawings to generate new visual forms, exploring the latent space of her own creativity in a process she describes as a dialogue with the machine. Rebecca Su, a professor of computer art, teaches her students to integrate AI into the pre-production phase of their projects. They use AI tools to rapidly generate concept art, explore different visual styles for character designs, and storyboard narrative sequences, using the technology as a powerful engine for brainstorming and inspiration before moving on to create the final work with their own hands. This emerging artistic practice suggests a shift in the artist's role from one of pure manual execution to one of conceptual direction, curation, and system design. The valuable skill is not merely the ability to craft a clever prompt, but the artistic vision required to design the entire creative process, select the data, and guide the technological tool toward a compelling outcome. 4. 3. The steal like an artist defense. Is all creativity derivative? A central philosophical argument in defense of AI's training methods is that all creativity is, to some extent, derivative. Human artists do not create in a vacuum. They learn their craft by observing, studying, and imitating the works of those who came before them. Renaissance apprentices spent years copying the works of masters to learn their techniques. Musicians learned scales and study compositions. Writers read voraciously to develop their style. As author Austin Kleon famously put it, "You are the sum of your influences." From this viewpoint, an AI model analyzing billions of images to learn the statistical patterns that constitute a cat, or the style of Van Gogh, is performing a hyper-efficient, scaled-up version of the same learning process a human artist undertakes. It is synthesizing a vast library of visual information to build an internal understanding of concepts, which it can then use to generate novel compositions. The argument is that if a human can learn from copyrighted works without it being considered theft, then a machine performing a similar function should be treated no differently. 4. Democratizing creativity. Art for everyone. Finally, proponents argue that one of AI's greatest strengths is its ability to democratize creativity by lowering the technical barriers to visual expression. An individual may have a powerful artistic vision, but lack the years of dedicated practice required to master drawing, painting, or digital sculpting. Text-to-image models provide a new avenue for these individuals to bring their ideas to life, making art creation more inclusive and accessible to a broader population. In this capacity, AI can function as an assistive tool, automating tedious or technically difficult tasks and allowing creators to focus on the higher-level conceptual aspects of their work. Despite the strong historical parallels in societal reaction, the analogy between AI and photography breaks down at the crucial point of creation, the locus of intent. A photographer wields the camera as a tool to execute a specific artistic vision. They make conscious, creative decisions about composition, lighting, focus, and the decisive moment to capture. The creative intent and control over the final expressive work reside firmly with the human operator. With current text-to-image models, the dynamic is different. The user provides a prompt, which the U.S. Copyright Office has likened to an unprotectable idea. The AI model then determines the expressive elements, the specific arrangement of shapes, colors, and textures, through its own complex and often opaque internal process. The fundamental legal and philosophical debate hinges on whether the act of writing a prompt constitutes sufficient creative control to be analogous to the art of photography. This key difference in the level of direct, granular control over the final output is what makes the acceptance of AI art as a legitimate artistic medium far more challenging than it was for photography. Section 5. The economic shockwave, market disruption and artist livelihoods beyond the abstract ethical and legal debates. The arrival of generative AI has triggered a tangible economic shockwave across the creative industries. The technology's ability to produce high-quality imagery at unprecedented speed and scale is fundamentally altering market dynamics, threatening the livelihoods of many artists while creating new opportunities for others. 5.1. The crowding out effect. A flood of supply, the most immediate economic impact of generative AI is a massive increase in the supply of digital images. A 2025 study from Stanford Graduate School of Business analyzed a large online stock image platform before and after the introduction of AI-generated content. The findings were stark. The number of new images uploaded to the platform per month skyrocketed by 78%. This flood of new content was driven almost exclusively by producers using AI tools. This supply shock had a direct and negative impact on human artists. The study found that the arrival of AI was accompanied by a 23% drop in the number of active non-AI artists on the site, suggesting they were either unable to compete and were crowded out, or they chose to exit a market they perceived as devalued. While the total number of sales on the platform increased by 39% due to the new variety and volume, sales of human-created, non-AI images decreased. This strongly indicates that consumers are treating AI-generated images as direct market substitutes for human-created stock imagery, a finding that directly supports the artist's claims of market harm in copyright lawsuits. 5.2. Devaluation of labor and the threat to livelihoods. The core economic fear for artists is that the efficiency of AI will lead to a fundamental devaluation of human creative labor. When clients can generate a good enough image for a project in seconds for a nominal fee, the demand for human artists for many commercial tasks, such as creating blog post illustrations, concept art, or social media graphics, is likely to decline. This threatens to increase artist precarity, a term describing the chronic financial and professional instability faced by many in the creative sector. This anxiety is widespread. A survey by the Academy of Animated Art found that 55% of artists believe AI will negatively impact their ability to generate income. These fears are not confined to visual artists. The 2023 strikes by the Writers Guild of America, WGA, and the Screen Actors Guild, SAG-AFTRA, which cost the California economy an estimated $6.5 billion, were driven in large part by the need to secure contractual protections against studios using AI to write scripts or replace background actors. This industrial action demonstrates that the threat to creative livelihoods is perceived as existential across the entertainment industry. the economic impact appears to be bifurcated, disproportionately harming what might be called the middle class of working artists. The low to mid end of the commercial art market, which relies on volume and efficiency, e.g., stock photography, straightforward graphic design, is facing the most severe disruption and price collapse due to direct substitution by AI. At the same time, the high end of the market, such as fine art sold in galleries or unique, high-concept commissions, may actually see the value of authenticated, human-made work increase due to its perceived authenticity, narrative, and scarcity. This dynamic threatens to hollow out the middle of the creative economy, making it increasingly difficult for artists to build a sustainable career through the kind of bread-and-butter commercial work that has traditionally supported them. 5. 3. The perceived value gap, a silver lining for human artists. While the market data on substitution is grim, other research reveals a potential silver lining for human creators. A 2024 study from Columbia Business School uncovered a significant consumer bias against AI-generated art. In a series of experiments, participants were shown identical images, with some labeled as human-made and others as AI-generated. On average, participants valued the art labeled as AI-generated 62% less than the art they believed was made by a human. This perceived value gap suggests that consumers do not value art based on its aesthetic properties alone. The story behind the work, the skill and labor of the artist, and the perceived human touch are critical components of its value. This finding provides a clear market strategy for human artists: differentiate and brand. By clearly labeling their work as human-made or not by AI, artists can tap into this consumer preference for authenticity and potentially command a premium price in a market flooded with machine-generated content. However, this value gap is a double-edged sword. Its existence relies on the consumer's ability to reliably distinguish between human and AI art. As generative models become more sophisticated, this distinction will become virtually impossible to make on visual inspection alone. This creates a powerful economic incentive for unscrupulous sellers to misrepresent their AI-generated work as human-made in order to capture the 62% value premium. Such a trend could lead to widespread fraud, eroding consumer trust and ultimately collapsing the very authenticity premium that was protecting human artists. The Not by AI badges and pledges emerging in creative communities are an early, informal attempt to solve this looming crisis of verification and provenance. 5. 4. New economic models. UBI and AI collaboration. Some observers argue that the economic disruption caused by AI is not a problem with the technology itself, but a failure of our economic systems to adapt to a massive leap in productivity. Rather than trying to slow down the technology, they propose systemic solutions. One such idea is the implementation of a universal basic income, UBI, a regular payment to all citizens that would provide a financial safety net. In such a system, artists would be free to pursue their creative passions without the constant pressure of market competition, creating art for its own sake rather than purely for commercial survival. Other artists are focusing on adapting their own business models. Instead of competing with AI, they are collaborating with it, using AI tools to enhance their own productivity and offer novel creative services. These can include creating personalized artwork for clients, generating unique assets for the NFT market, designing templates for businesses, or offering AI-assisted art consulting services. This approach reframes the artist as a creative director, leveraging AI to expand their capabilities and market reach. Section 6. The digital resistance, countermeasures and the path forward. In response to the perceived threats of data scraping and style mimicry, artists and their allies have moved beyond legal challenges and public advocacy. A new front has opened in the conflict, a technological one. Researchers are developing sophisticated tools designed to give artists agency over their work in the digital realm, creating a form of digital resistance. This, combined with a growing call for regulatory action, points toward a future where the relationship between AI and art will be shaped by a combination of code, contracts, and law. 6. 1. Poisoning the well. The rise of defensive tools recognizing the limitations of the legal system. Computer science researchers at the University of Chicago have developed two powerful tools designed to help artists protect their work from being ingested by AI models: Glaze and Nightshade. Glaze is a defensive tool designed to protect individual artists against style mimicry. It works by applying subtle, nearly imperceptible changes to the pixels of an image. To a human viewer, the artwork looks virtually unchanged. To an AI model, however, these changes act as a style cloak, confusing its ability to analyze and replicate the artist's unique aesthetic. An artist can glaze their work before uploading it online, making it a less useful sample for any model attempting to learn their style. Nightshade is a more aggressive, offensive tool that acts as a poison pill for AI training datasets. Like Glaze, it alters an image in ways that are difficult for humans to see. However, instead of just cloaking style, Nightshade corrupts the model's fundamental understanding of concepts. If a model is trained on a sufficient number of images of dogs that have been poisoned by Nightshade, it might learn that dogs have long, pointy ears and whiskers. Subsequently, when a user prompts the model for a dog, it might generate an image of a cat. The goal of Nightshade is not to destroy models, but to make the practice of scraping unconsented data so unreliable and costly for AI companies that they are economically incentivized to switch to a model of licensing data with artists' permission. The development and adoption of these tools represent a significant escalation in the conflict. The battle is moving from the courtroom into the code itself, creating a technological arms race. As artists deploy tools like Glaze and Nightshade, AI companies will inevitably work to develop countermeasures to detect and filter out this poisoned data. This, in turn, will spur the development of more sophisticated cloaking and poisoning techniques. This cycle of adversarial technological development shifts the dynamic from a legal dispute to a perpetual cat-and-mouse game fought with algorithms, which could have unpredictable consequences for the stability and reliability of future AI models. 6. 2. The regulatory horizon. Crafting new rules. The manifest inadequacy of 19th-century copyright law to address 21st-century technology has led to widespread calls for new legislation and regulation. Several potential frameworks are being debated to create a more equitable ecosystem. Opt-out versus opt-in. A central policy debate revolves around where the burden of consent should lie. The current default is an opt-out system, where AI companies can scrape any publicly available data unless a creator takes proactive steps to block them. Artist advocacy groups argue this is fundamentally unfair and ineffective, as most creators are unaware of or unable to implement these technical measures. They are pushing for an opt-in system, which would require AI companies to obtain explicit permission from rights holders before including their work in a training dataset. Mandatory licensing frameworks. Another proposed solution is the creation of compulsory licensing systems, similar to those that govern the use of music in radio broadcasting or public venues. Under such a framework, AI companies would pay royalties to a central collecting society, which would then distribute the funds to artists whose works were used for training. This would ensure creators are compensated for the value their work provides without stifling innovation. Disclosure and transparency. In the United States, the proposed Generative AI Copyright Disclosure Act would mandate a new level of transparency. If passed, it would require AI companies to file a comprehensive list of all copyrighted works used in their training datasets with the U.S. Copyright Office before a new model could be publicly released. This would give creators clear insight into whether their work has been used and provide a stronger evidentiary basis for legal action. The ultimate resolution of this conflict is unlikely to come from a single court case. The core issues are fundamentally economic and political, concerning the distribution of value and power in the creative economy. While lawsuits are a crucial lever for change, the most durable solutions will likely emerge from policy, regulation, and collective action. The Hollywood strikes serve as a powerful precedent. A resolution was achieved not through a judicial ruling on fair use, but through collective bargaining that forced a new economic and contractual arrangement between creators and corporations. The future will be shaped less by the specific outcome of any single lawsuit, and more by the ability of creators to organize and advocate for a new legal and economic framework that rebalances the scales. 6. 3. Conclusion. Reconciling inspiration and theft in a new social contract, the rise of generative AI art has placed society at a crossroads, forcing a confrontation with fundamental questions about the nature of creativity, the value of human labor, and the ownership of ideas in the digital age. The central query, whether AI art is a product of creative inspiration or high-tech theft, resists a simple answer because, in its current form, it is undeniably both. The element of inspiration is undeniable. The technology itself is a monumental achievement, capable of acting as a powerful tool for brainstorming, a collaborator for exploring novel aesthetics, and a means of democratizing visual expression for millions. In the hands of visionary artists, it has already opened up new frontiers of creativity, echoing the transformative impact of past technological disruptions like photography. To dismiss this potential is to ignore a long and fruitful history of art and technology evolving in tandem. Yet, the element of theft is equally undeniable, embedded not in the technology itself, but in the dominant business model that has fueled its rapid development. This model has been predicated on the mass, unconsented, and uncompensated appropriation of the collective creative output of humanity. By scraping billions of copyrighted images from the internet and treating them as a free resource to be refined into proprietary, commercial products, the developers of these models have broken a foundational social contract with creators. The path forward does not lie in banning a transformative technology. Rather, it demands a fundamental reformation of the practices surrounding it. The current paradigm, which pits technological progress against the rights and livelihoods of artists, is unsustainable. It must be replaced by a new social, legal, and economic contract that establishes clear and enforceable rules for data provenance, creator consent, and fair compensation. This new contract will be forged in courtrooms, in legislative chambers, and through the continued resistance and innovation of artists themselves. It will require moving from ineffective, opt-out systems to frameworks that respect a creator's right to opt-in. It will likely involve the creation of new licensing bodies to ensure value flows back to the creators whose work provides the foundation for these systems. And it will be accelerated by technological countermeasures that force a shift from a model of appropriation to one of permission. The future of art will not be one of humans versus machines. It will be one of human artists wielding ever more powerful machines. The critical task ahead is to ensure that the systems we build are not only technologically brilliant, but also ethically sound, creating an ecosystem that values and rewards both the algorithmic marvel and the irreplaceable human soul at the heart of all art.